voltage, or electric potential difference, can be a really difficult thing to wrap your brain around. I mean, you probably know this is a 9-volt battery, and you know to stay away from high voltage power lines. You might even know that the outlets in your home provide 110 volts of electricity, but if you go to Europe, most of the voltage is at 220. So what is voltage? And why do we call it electric potential difference? Well, it has something to do with energy, so let's start there. Here's our definition from class. Electric potential difference, or voltage, is equal to the change in energy divided by charge. Okay, so we can see there's a change in energy in this formula. That's part of where the idea of a difference is coming from in the name. What is the charge referring to? Q in our formula refers to the magnitude of charge of an object moved into an electric field, like this charge placed in this electric field, which is acting to the left. We know that an electric force will act on the particle. And since it's a negative charge particle, the electric force acts to the right. And that the object's going to move through some displacement, which we'll call d. In this case, it's also to the right. This means there was work done on the object by the electric field because it had a force applied to it and it moved over a displacement or a distance. And you might remember this from back in Science 10 and Physics 20. And if work is done on the charge by a force, that must mean that there was a change of energy present. Now, if all of this confuses you, here's what I want you to focus on. Electric potential difference is the change in energy. It's the amount of energy that is gained or lost by a charged particle per unit of charge. Now, I know the word per can cause a lot of confusion, so here's an example. Let's say I hire you to mow my lawn, and we agree that I'll pay you $10 per hour. So I guess you could work out your pay with a simple equation. Your pay equals the number of hours you work times the amount of dollars per hour. So if it takes you 2 hours to mow the lawn, I pay you 2 hours times $10 per hour, which is $20 of pay. But if it only takes you a quarter of an hour, I pay you 0.25 hours times $10 per hour, which is $2.50 of pay. Now let's say you are a negatively charged particle. And I don't let negatively charged particles mow my lawn, so I'm going to hire you to move through this electric field. As a charged particle, you don't care about money, you care about energy. The amount of electric potential energy you gain or lose when you move through this field is represented by the equation energy equals charge multiplied by electric potential difference, which is just the same equation we were looking at before, but rearranged. Let's say I ask you to move through an area of space where the electric field creates an electric potential difference of 10 volts, or 10 joules per coulomb. And maybe you have 1 coulomb of charge, so moving through this electric potential difference means you'll gain or lose 10 joules of electric potential energy. And maybe you have a friend who has a negative charge of magnitude 0.25 coulombs. Your friend also moves through an electric potential difference of 10 volts, so your friend will gain or lose 0.25 joules of electric potential energy. One of the key ideas here is that we're talking about energy change. And in the example that I've shown you in this video, we're talking about a change in energy that starts off as electric potential energy that's stored in that charge by the electric field, and then it turns into kinetic energy in movement of the charge. And this is a really common kind of problem in Physics 30. So if you'd like to see a few examples of how to work that out, you can go check out these 2 videos.